Given the function f of x equals cosine of x plus the square root of 3 sine of x on the interval 0 to 2 pi, we want to find any local and absolute maximum and minimum inflection points, and then we sketch the graph. To find the minimum and maximum, we would need the first derivative. The first derivative is f prime of x equals the derivative of cosine of x is negative sine of x plus the square root of 3, and the derivative of sine of x is cosine of x. We then set this equal to 0 and solve for x. We first isolate negative sine of x to get negative root 3 cosine of x, and then we divide by both sides of the equation by negative cosine of x. The left hand side is now tangent of x, and the right hand side is positive the square root of 3. Positive square root of 3 can be written as root 3 over 2 over 1 over 2, and so tangent of root 3 occurs at x equals 1/2 and y equals root 3 over 2. There is another point in the third quadrant as well. At this point, the angle is pi over 3, and in the third quadrant, the angle is 4 pi over 3. And so the solutions between the interval 0 to 2 pi is x equals pi over 3 and x equals 4 pi over 3. These two are the critical values. These two critical values provide the cut points in the interval 0 to 2 pi, and we use them to test the sign of f prime. The sign of f prime will tell us where the extreme values are. The critical values are pi over 3 and 4 pi over 3. If we pick a number between 0 and pi over 3, x equals pi over 4 will work. A number between pi over 3 and 4 pi over 3, x equals pi would work. And a number between 4 pi over 3 and 2 pi, x equals 3 pi over 2 would work. We plug these into the first derivative. These are what we call the test point, because the sign of the first derivative at this particular point will determine the sign of the first derivative on the entire subinterval where this test point lies in. F prime of pi over 4 is negative sine of pi over 4 plus the square root of 3 cosine of pi over 4. And this is negative root 2 over 2 plus the square root of 3 root 2 over 2. And we see that this is a positive number. And so f prime is positive on the interval 0 to pi over 3. We then plug in pi into the first derivative, negative sine of pi plus the square root of 3 cosine of pi. Negative sine of pi is 0 plus the square root of 3 cosine of pi is negative 1. And so this is a negative number. The sign of the first derivative on the interval pi over 3 to 4 pi over 3 is therefore negative. And lastly, we plug in 3 pi over 2 into the first derivative to get negative sine of 3 pi over 2 plus the square root of 3 cosine of 3 pi over 2. This is negative, and sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0, and this is 1, so it is positive. And so we see that the function f is increasing, and then decreasing, and then increasing. We have a local maximum at x equals pi over 3. We also have a local minimum at x equals 4 pi over 3. To find the local maximum value of the function, we would need to plug in pi over 3 into the function f. This is cosine of pi over 3 plus the square root of 3 sine of pi over 3. Cosine of pi over 3 is 1/2 plus the square root of 3. Sine of pi over 3 is root 3 over 2. This is from the unit circle. This is 1/2 plus 3 over 2, or 4 over 2, which is 2. The local maximum value occurs at x equals pi over 3 on the interval 0 to 2 pi, and the value is 2. For the local minimum value, we would plug in 4 pi over 3 into the function cosine of 4 pi over 3 plus the square root of 3 sine of 4 pi over 3. 4 pi over 3 is an angle in the third quadrant with the x-coordinate of -1/2 and the y-coordinate -√3 over 2. And so cosine of 4 pi over 3 is -1/2 plus √3. Sine of 4 pi over 3 is √3 over 2, and it is negative. This is -1/2 minus 3 over 2, and so it is -4 over 2, or -2. The local minimum value is -2, and it occurs at x equals 4 pi over 3. We now obtain the local max and the local mean. We still need the inflection point. To obtain the inflection point, we would need to find the second derivative. The first derivative was negative sine x plus the square root of 3 cosine of x. The second derivative, f double prime of x, is the derivative of negative sine of x is negative cosine of x plus the square root of 3. The derivative of cosine of x is negative sine of x. Simplifying this, we have negative cosine of x minus √3 sine of x, and we still need to set it equal to 0. Using this method that we did earlier, we would isolate negative √3 sine of x. The right hand side is positive cosine of x. Sine of x over cosine of x equals -1 over √3. And we rewrite this ratio at -1 over 2 over √3 over 2. Or it can be 1 over 2 over -√3 over 2. And so this is a angle in either the second quadrant or the fourth quadrant, because in the second and the fourth quadrant, tangent is negative. In the second quadrant, x is negative and y is positive, and so cosine is the first coordinate. Cosine is therefore -√3 over 2, and sine is 1/2. In the fourth quadrant, x is positive and y is negative. The angle that corresponds to the terminal side in the second quadrant is 5 pi over 6, and the angle that corresponds to the terminal side in the fourth quadrant is 11 pi over 6. And these are the two zeros of the second derivative. With these two zeros, we're going to test the sign of the second derivative. We draw the number line, but only from 0 to 2 pi. The two zeros for f double prime that we found is 5 pi over 6 and 11 pi over 6, not drawn to scale. We then choose a test point in each of these intervals. For the interval 0 to 5 pi over 6, we might want to use x equals pi over 2. And for the integral 5 pi over 6 to 11 pi over 6, we will use x equal pi, or any number in this interval. And for the last subinterval, we will use 11.5 pi over 6, because we want to pick a number that is between 11 pi over 6 and 2 pi. The second derivative that we found was f double prime of x equals negative cosine of x minus √3 sine of x. And so we plugged in pi over 2 into the second derivative. This is negative cosine of pi over 2 minus √3 sine of pi over 2. Cosine of pi over 2 is 0. minus root 3 times sine of pi over 2 is 1. So this is negative. F double prime is negative in the subinterval 0 to 5 pi over 6. We then plug in pi into the second derivative, evaluate this, and we will see that it is positive. And so f double prime is positive in the second subinterval. We then plug in 11.5 pi over 6 into the second derivative, and we will see that this is negative. And so f double prime changes its sign at 5 pi over 6 and 11 pi over 6. We will end up with an inflection point at 5 pi over 6 and another inflection point at 11 pi over 6.